Okay, so what I've drawn here is a diagram of the Earth and the Moon. And you probably know, because you took astronomy, that the Earth has an attraction, gravitational attraction for the Moon, and the Moon has gravitational attraction for the Earth. Let's look in detail about what happens as a result of that. All right, now the Earth is about 75% water on its surface. Okay, so most of the Earth, in fact, is liquid water. When the Moon is attracting the Earth gravitationally, it's actually pulling on this water. I'm going to blow this up a little bit. And what I've drawn here are bulges of water on either side of the Earth. There are two bulges, one that is closer to the Moon. There's the Moon, hold on. There's the Moon. And on the other side, there's also another bulge. And we don't really need to go into the reason why there are two bulges. Let's just accept the fact that there are. One is closer to the Moon and one is farther away from the Moon. Okay? We also know that the Earth is rotating on its axis. And if we were in this view looking down on the North Pole, here, there's an X showing where the North Pole is, and we were looking at the Earth spinning, the Earth would be spinning counterclockwise. Okay? Okay, so I've drawn a picture of a person standing on the top of the Earth, and as the Earth is rotating, of course, that person is going to be riding the Earth as it's rotating. It's important to understand that as the Earth is rotating, the Earth is actually rotating under this layer of water. This layer of water is kind of fixed in a sense, where this bulge is always pointing toward the Moon, okay? And as that bulge is pointing toward the Moon, the Earth is rotating underneath it, okay? And you saw this person started out here, and then as the Earth was rotating, the water got deeper and deeper and deeper as the day went on. As the day progressed, this person went from being at a point of low tide to a point of high tide. As the Earth was rotating, the bulge of water stayed where it is, and the person actually rode into that higher amount of water through the course of the day. We went from a low tide to a high tide, and as the day would progress further, this person would be riding on the top of the Earth, just like you and I are, and would be moving into another place of low tide, and then throughout the course of the day into another place of high tide, and then low tide again. So throughout the course of the day, we have a low tide, a high tide, a low tide, a high tide, and another low tide. That is a 24-hour period, more or less. Actually, it's a little bit more than that, but let's just leave it at that. Okay, well, so far all we've considered really is the gravitational attraction between the Earth and the Moon. The Sun is also going to play a role here, so things get a little bit more complicated, not really. But we also want to consider the influence of the Sun now. Okay, so there's our Sun. Now, when we took astronomy, we also studied the phases of the Moon, and we're going to kind of go back to that a little bit now. Okay, what we're looking at right now is the phase of the Moon called new moon. Okay, new moon, I hope you remember that. 7 days later, we would be seeing a first quarter moon, and now the moon and the sun would be perpendicular to each other. By 14 days, we would have a full moon. By 21 days, we would have a third quarter moon. And then a full 28 days after we started our lunar cycle, we would have a new moon again. Okay, let's take a look at new moon again. And let's consider the fact that there is a gravitational attraction between the Earth and the moon right now. But on top of that, there's also a gravitational attraction between the sun and the Earth. In fact, the forces of gravity here are adding on to each other. The force of the moon on the Earth and the force of the sun on the Earth are added together. When the moon and the sun are in this orientation and their gravitational forces are adding on to each other, we call this a spring tide. Okay, spring tide. It has nothing to do with the season spring. Okay, during a spring tide, we have an especially high tide and an especially low tide. The high tide is especially high because on this side of the earth, we're getting an extra pull on that water, and that water is getting pulled away. Okay, if that water is getting pulled away, you can imagine that the low tide is going to be especially low. All right, so let's consider what would happen now when we're at a first quarter moon. We're still going to have the moon's attraction for the Earth. We're also going to have the sun's attraction for the Earth. But now the force of gravity by the moon and the force of gravity by the sun are, in a sense, kind of canceling each other out. And what we're going to end up with here is going to be an especially low high tide and an especially high low tide. We call this a neap tide. Okay, so a neap tide is going to happen when the moon and the sun are kind of acting against each other. Okay, the pull of gravity by the moon on this water for high tide is going to be lower than usual, and the low tides will be especially high because of that also. So remember, neap tide, low high tide, high low tide, spring tide, high tide, and low tide. We're going to see another spring tide when we get a full moon, and we're going to see another neap tide when we get a 3/4 moon. Please also refer to the PowerPoint in which there are some diagrams there that might help you understand this a little bit better. I just wanted to have this chance to kind of talk it through with you. Thanks, guys. Okay, everybody, today we're going to talk about how do the tides work. So what are tides? If you've ever spent any time near the ocean or the sea, you've probably noticed that the sea level rises and falls depending on the time of the day. So the definition of tides is fluctuations in local sea level due to the gravitational attraction of the moon and the sun. And today we're going to talk about exactly how this happens.